Let's look at why AB quantity to the nth equals a to the nth over b to the nth is true. So based on looking at the numerator up here on the right side, a is a base, so let's not plug in a number for that. Same deal, b is a base, so we're not going to plug in for that. N is an exponent, we're only going to plug in for the exponent. Again, this is the one exception we are making to how you show a formula is true. Generally speaking, you would never plug in for a variable to show a formula is true. The one exception I am allowing, because this is sort of a concrete way to deal with this, is to plug in just for the exponents. Okay, and this is just to be able to count how many times a base appears. Now take a look at the left side. AB to the n becomes AB to the third, and to the third means, well, multiply that fraction by itself a total of 3 times. So a over b times a over b times a over b. And if we do what fraction multiplication looks like, we should just multiply straight across. A times a times a times b times b times b. On the right side, it said a to the nth over b to the nth. And if we go ahead and substitute 3 for all the n's, we'll have a to the third over b to the third, which if we spell out what that means, it's a times a in the numerator and b times b in the denominator. Take a look. The left and the right side became the same. So that's going to be our explanation. Just as a reminder here, when multiplying fractions, just be sure to multiply straight across. There is an alternate way to display the answer to this question. So if you like what's written here, great. But another way to do this is to do valid algebra steps starting with the left side to eventually get what's on the right side. So this is essentially the same work. I start with the left side, a over b to the nth, just replace the n with a 3. So a over b to the third, that's a over b times a over b times a over b. Do the fraction multiplication, a over b, which is a cubed over b cubed, which just unplugging in the n. So replacing the 3 now back with an n, you have a to the n over b to the n, and that is the right side of the formula. So it's just a different approach. It just organizes the same work that was up here in a different format. Some will find this more convenient because it's all in one line. If you'd rather just break the left and right side down and simplify them and point and say, oh, look how these are the same, that works just fine too. Just be really careful. Based on what we just did, I ask you to please be careful when writing fractions. If you write like this, it's kind of unclear. Where does that cube go? If somebody writes, it's part of it is the unfortunate thing is how short that fraction bar is. I mean, is the cube only applying to the a? Is it applying to the fraction? So does this mean a cubed over a b, which would be clear due to that fraction bar being longer and where the cube is written, or does this mean a over b quantity cubed? We just saw that a over b quantity cubed becomes a cubed over b cubed, and this is different than that, right? So this thingy here, right, becomes, so a over b quantity cubed becomes a cubed over b cubed, but this is different from that. So it's important to be really clear. So be clear when writing fractions. So make sure if you have exponents dealing with fractions, if you mean to cube the entire fraction, use parentheses and make sure your fraction lines are long enough and short enough to clearly communicate what you need to. Here's another place that sometimes writing is unclear. Diagonal fraction lines are often unclear, not always. So if you just write 3/4 like this, that's pretty clear to me that this is 3/4, okay? But when somebody writes like this, and sometimes do they mean 3/4 and then times an x, or is this 3 over 4x, right? Is the x just being multiplied by the 4? Or is this the fraction 3/4 times the variable x? Yeah, if it's 3/4 times the variable x, that's one thing. That will simplify a different way than 3 over 4x. So just to really clarify, I just would like to show that 3/4 times x, which is written down here, look, we've got, does not mean distribute the x on top and bottom. This is x over 1, right? So then we got fraction times finally another fraction, multiply straight across. This is 3x over, right, 3 times x, so 3x over, and then 4 times 1 is 4. So this is, writing like this is so unclear. It's either 3x over 4 or 3 over 4x. It's like, does the x end up in the numerator or in the denominator is really kind of ultimately what happens when you simplify. So you've got to be very careful about writing fraction lines that are diagonal because it can be unclear which of these two things you mean. Okay. All right. So one more true formula here, and this one's a bit of a challenging one in that it relies on some other true formulas we have already seen. So y is a to the mth over a to the nth equal to a to the m minus n? Well, the technique we're going to use to show this is true is we're going to start with the left side. And then we're going to keep applying processes that we've previously said were okay. So we'll eventually get to what's on the right side. So here's how it goes. Take the left side, and this next step looks peculiar, but I'm going to rewrite this as a to the m over 1 times 1 over a to the n. Now what's going on here is if you had these two fractions and you were asked to multiply and simplify, you would just multiply straight across, right? So a to the m times 1 would be a to the m, and 1 times a to the n would be a to the n. So this is really peculiar as a step. It looks like we're going backwards, and in a sense we are. We're using the fraction multiplication rule, the simplifying rule, and unsimplifying, right? We're doing things in reverse. But this will work out because now take a look. A to the m over 1 is just a to the m, and 1 over a to the n, you'll look at our earlier exponent rules, and this is a to the negative n. Now take a look. When you have things with the same base, you add the exponents. That, in fact, so adding the exponent m and negative n, that uses this formula. This is why we presented the when multiplying things with the same base, you add the exponents formula. I presented this using new variables specifically for using it right here. And then m plus negative n you can rewrite as m minus n. So look, we've now obtained what's on the left side. What's on the right side. We started with the left side, and then we did valid algebra manipulations. All of the steps are justified by things that we said were allowed earlier. And we eventually got a to the power m minus n. We could have started on the right and worked in reverse. That's just all the steps in reverse.